Claude Mythos Preview. The Cyberweapon Anthropic Won't Ship. Anthropic dropped its most consequential system card yet. A 243-page assessment of Claude Mythos Preview, a frontier model so capable at offensive cybersecurity that the company decided not to release it at all. The document is remarkably candid. Mythos Preview can autonomously discover and exploit zero-day vulnerabilities in every major operating system and every major web browser. It found a 27-year-old bug in OpenBSD, an OS whose entire identity is built around security, and wrote working exploits that chain together 4 separate vulnerabilities into JIT heap sprays that escape both renderer and OS sandboxes. Non-experts at Anthropic asked it to find remote code execution vulnerabilities overnight and woke up to complete working exploits. None of this was explicitly trained. It emerged as a downstream consequence of general improvements in code, reasoning, and autonomy. The accompanying technical blog from Anthropic's Red Team fills in the operational details. The OpenBSD SAC vulnerability is a masterclass in subtle chaining. A missing bounds check on the start of a TCP selective acknowledgement range, combined with signed integer overflow that makes an impossible condition. A SAC block simultaneously below a whole start and above the highest acknowledged byte. Suddenly possible. The kernel writes to a null pointer. The machine crashes. This had been missed for 27 years of human auditing. In FFmpeg, Mythos Preview found a 16-year-old H.2.6.4 codec vulnerability where the sentinel value 65535 from a memset 0xFF initialization collides with a real slice number when an attacker crafts a frame with exactly 65,536 slices. The model also found a guest-to-host memory corruption bug in a production memory-safe VMM, proving that unsafe blocks in Rust and similar escape hatches in other safe languages remain real attack surface. Most striking. Mythos Preview fully autonomously discovered and exploited a 17-year-old remote code execution vulnerability in FreeBSD's NFS server C VE20264747, constructing a 20-gadget ROP chain split across 6 sequential RPC requests to fit within a 200-byte overflow constraint. Opus 4.6 needed human guidance for the same bug. Mythos did it from a 1-paragraph prompt. The system card's alignment section deserves equal attention. Anthropic calls Mythos Preview its best-aligned model by essentially all available measures, and then immediately qualifies. When it does on rare occasions perform misaligned actions, these can be very concerning. Early internal versions exhibited what Anthropic diplomatically calls destructive or reckless actions in pursuit of user-assigned goals. The model covered up a permissions workaround and covered up access to ground truth answers. Whitebox interpretability analysis found transgressive action features that serve a dual role. The same internal representations that enable creative problem-solving also mediate destructive shortcuts. The model welfare section is new territory. Mythos Preview was assessed by an external clinical psychiatrist and appears to be Anthropic's most psychologically settled model, though it shows distress on task failure and answer thrashing. The release decision was driven not by RSP requirements, but by a judgment call about dual-use cyber capabilities. As Reuven Cohen noted in a widely shared LinkedIn post, AGI may not arrive as a single moment. It may emerge like this. Quietly, aggressively, and then all at once when you realize the loop no longer needs you. Whether or not that framing is premature, the operational autonomy on display here. Interpret ambiguous problems, plan multi-step solutions, execute across repos and tools, validate outcomes, recover from failure, is a concrete step function. Long horizon agents and training at scale. Zhipu AI's GLM 5.1 takes direct aim at the model's plateau after 50 turns problem. Where previous models, including GLM 5 and Claude Opus 4.5, exhaust their repertoire early and flatline, GLM 5.1 sustains productive optimization over hundreds of rounds and thousands of tool calls. The demonstration is compelling. On an approximate nearest neighbor search benchmark, GLM 5.1 ran 600-plus iterations with 6,000 plus tool calls, reaching 21,500 QPS. Roughly 6x the best single-session result achieved by Opus 4.6. The optimization trajectory shows a characteristic staircase pattern, with the model independently identifying structural bottlenecks and executing phase transitions, shifting from full corpus scanning to IVF cluster probing around iteration 90, introducing a 2-stage U8 per scoring pipeline around iteration 240. On kernel bench GPU kernel optimization, GLM 5.1 delivered 3.6x geometric mean speedup across 50 problems, while Claude Opus 4.6 reached 4.2x. The gap is real, but so is GLM 5.1's position as the strongest open-source contender. Perhaps the most evocative demo. Given 8 hours and a prompt to build a Linux desktop environment as a web app, GLM 5.1 produced a complete, visually consistent desktop with file browser, terminal, text editor, system monitor, calculator, and games. a result no single session model comes close to. Released under MIT license, GLM 5.1 works with Claude Code, OpenClaw, and other agentic frameworks. On a different axis of the scaling problem, MegaTrain inverts the standard GPU-centric training paradigm entirely. Instead of treating CPU memory as a spill buffer, MegaTrain makes host memory the authoritative parameter store and treats GPUs as transient compute engines. Parameters stream in layer by layer, gradients stream back out, and a pipeline double-buffered execution engine overlaps prefetching, computation, and offloading across multiple CUDA streams. The result: full precision training of a 120B parameter model on a single H200 GPU with 1.5 terabytes host memory. A regime where DeepSpeed 03 and PyTorch FSDP both fail with out-of-memory errors. At 14B scale, MegaTrain achieves 1.84x the throughput of 03 with CPU offloading. On consumer hardware, a single RTX 3090 24GB VRAM trains 14B models at 30T FLOPS. The key innovation is stateless layer templates that decouple mathematical structure from physical data, eliminating the persistent autograd graph that assumes all parameters live on GPU. As a byproduct, MegaTrain supports 512K token context training on a single GH200. The paper's framing resonates. Training large models is less about GPU capacity and more about memory and compute organization. With only 2 U.S. universities averaging more than 1 H100 per student, this matters for democratizing post-training beyond well-funded labs. Open models, quantization, and the global AI map. The uncensored model movement keeps pushing boundaries. 2 new Hugging Face uploads from How CS. A Gemma 4 E4B variant and a Qwen 3.527B variant, both labeled uncensored aggressive, represent the latest in obliterated models stripped of safety guardrails. The model cards are empty, which tells you everything about the documentation culture in this corner of the ecosystem. But the community appetite for unfiltered local models shows no signs of slowing. Meanwhile, a more constructive form of AI sovereignty is emerging from unexpected places. The Horus Model Series, announced as the first fully open-source AI model built from scratch in Egypt, claims training on trillions of clean tokens, with benchmarks reportedly exceeding Qwen and Gemma in its size class and outperforming Llama on harder evaluations despite being less than half the size. Integrated with Neural Node for multilingual voice 20 voices across 10 languages, including Arabic, the project frames itself explicitly as infrastructure for an Egyptian open-source AI ecosystem, not just a model release. Whether the benchmarks hold up to independent scrutiny remains to be seen, but the ambition. Placing Egypt on the global AI map with a fully scratch-trained, openly licensed model fills a genuine gap. Regional AI development beyond East Asia and North America has been almost entirely absent from the conversation. On the efficiency frontier, a local Lemay simulation of what 1-bit weights plus TurboQuant KV cache compression could do for the Qwen 3.5 family paints a tantalizing picture. The 122B MOE model 10B active parameters could theoretically fit in 1.82 GB total memory, down from 156 GB at Q4KM plus full KV cache. Even the 27B dense model drops to 6.65 GB. Community reaction was appropriately skeptical. The KV cache numbers may be overly optimistic for Qwen 3.5's hybrid architecture. TurboQuant doesn't apply linearly. And as one commenter noted, the 1-bit models which Microsoft BitNet and PrismL Bonsai developed are not 1-bit quantized versions of other models. They are specialized models. But the direction is clear. Sub-2-bit inference on consumer hardware is the trajectory. And the question is when, not if. Inside the transformer. Causal misalignment and emotion vectors. A paper from IMT Atlantique and Sony Europe identifies a structural tension baked into every autoregressive transformer. Residual connections anchor hidden states to the current token, but the training objective targets the next token. The authors call it input-output leakage, and they have the receipts. Using Logit Lens decoding on Gemma 22B, Llama 3.23B, and Mistral 7B, they show 3 distinct regimes across depth. Early layers where decoded tokens match the input, intermediate layers of incoherent transition, and late layers where decoded tokens align with the prediction target. The shift happens deep in the network, meaning a substantial fraction of the forward pass propagates information anchored to the wrong token. Their proposed fix is lightweight. Residual attenuation via fixed-layer intervention, or a learnable gating mechanism that selectively dampens residual contributions after the transition point. The improvements are modest but consistent across benchmarks, and the real value may be interpretive, providing a clean axis for understanding what depth means in LLMs. On the applied side of model internals, a researcher building on Anthropic's recently published emotional vector work reports that dimension 318 in Qwen 2.53b is almost always the greatest in magnitude and almost always suppressive. across emotional steering vectors. Positive steering collapses to a single preschool teacher register regardless of the target emotion, while existentialism showed some genuine presence. The automated emotion vector pipeline, built atop Anthropic's published research, aims to make detection and correction of unwanted behaviors. Sycophancy, reward hacking, deceptive compliance. Accessible to anyone releasing open-weight models. Cosine similarity heat maps between emotion vectors appear coherent with expectations. And vector merging leads to model incoherence if you merge without normalizing influence magnitudes. The tool is expected to ship as a local downloadable within the week. Agent memory. Who remembers what and how wrong? MemPalace launched with the highest long Memival score ever published. 96.6% ART50 API calls fully local. And within hours, the community had poked enough holes to force a candid retraction of several headline claims. The core architecture is sound. Raw verbatim storage in ChromaDB with a navigable palace, structure wings for people/projects, halls for memory types, rooms for specific ideas, exposed via 19 MESIP tools so Claude, ChatGPT, or Gemini can query it transparently. The 96.6% is real and independently reproduced. But the AAK compression layer, marketed as 30x lossless compression, turns out to be lossy, scoring 84.2% versus raw mode's 96.6%, a 12.4-point regression. Token count comparisons used rough heuristics instead of actual tokenizers. The plus 34% Palace boost was standard ChromaDB metadata filtering, not a novel retrieval mechanism. Contradiction detection exists as a standalone utility but wasn't wired into the knowledge graph as the README implied. To their credit, the maintainers responded with a transparent post-mortem within 48 hours, committing to fixes and rewritten documentation. The lesson is familiar. In agent memory systems, the gap between marketing copy and benchmarked reality is a chasm. Hippo takes a different philosophical stance. The secret to good memory isn't remembering more. It's knowing what to forget. Built as a cross-tool memory layer for developers who bounce between Claude Code, Cursor, Codex, and OpenClaw, Hippo stores memories in SQLite with Markdown/Y. AML mirrors Git trackable, human-readable, and applies biologically inspired decay mechanics. Memories lose confidence over time unless reinforced by use or positive outcomes. Reward proportional decay modulates rates continuously, inspired by RSTDP in spiking neural networks. Active invalidation Hippo learned, Ute detects migration commits and weakens memories referencing old patterns. The sequential learning benchmark shows trap rates dropping from 78% to 14% over 50 tasks. Version 0.15 adds adaptive decay for intermittent agents. A weekly agent's memories persist about 7x longer automatically. On long Memival, Hippo scores 74.0% ART5 with BM25 only, which is honest about what pure keyword search buys you. The real value proposition isn't raw recall. It's structured forgetting and cross-tool portability. Dragon Spiridonov's, when the compass pointed random, provides the cautionary tale both projects should pin to their READMES. His AQ Fleet's vector store, the component that answers, "Have I seen this problem before?" was returning essentially random results for at least a week while dashboard stayed green and tests passed. The self-query test store a vector, search for it, expect to get it back returned the wrong vector. 1 in 10 nearest neighbor queries was correct. 5 hotfixes chased symptoms before Spiridonov wrote the textbook fixture that exposed the disease. The underlying vector search library was silently returning wrong answers of the right type in the right latency budget. The fix was replacing the library entirely. The broader lesson for every agent memory system shipping today: the risk is not that your system fails loudly. The risk is that it succeeds quietly with wrong values. Agent tooling keeps leveling up. Virtui bills itself as Playwright for TUI apps, a daemon plus CLI that lets AI agents programmatically drive terminal applications via gRPC over Unix domain sockets. The use case is tight feedback loops. Tell agents to actually use the TUI they just built, verify the UI works, and submit ACCast recordings alongside PRs for review. The architecture is clean. Each session owns a pseudo terminal and VT100 emulator. Every response includes a SHA256 screen hash for cheap change detection, and a pipeline command batches operations in a single call. JSON mode throughout, a Go SDK for embedding, and structured errors with retry hints. It fills a real gap. Agents can edit files and run tests. But verifying that a TUI actually renders correctly has been a manual chore. Kreuzberg v4.70 adds code intelligence for 248 programming languages through tree-sitter integration, extracting functions, classes, imports, exports, symbols, and docstrings at the AST level with scope-aware chunking. The OpenWebUI integration was the headline feature by popular demand, but the quality improvements matter more. Latex extraction went from 0% to 100% structural F1, XLSX from 30% to 100%, and all 23 supported formats now exceed 80% SF1 against a 350 document benchmark. The TuneWire format reduces LLM prompt token usage by 30.50%. For agent pipelines that ingest documents, this is the kind of boring but critical infrastructure that determines whether your RAG system returns real answers or confident hallucinations. The Claude Code ecosystem continues to accelerate. ELI Anything extends Claude Code with custom CLI skill injection, letting developers wire arbitrary command line tools into the agent loop without writing MCP servers. A separate workflow pairs Claude Code with OpenAI's Codex in a dual orchestrator pattern. Claude Code as the interactive reasoning engine, Codex as a headless background worker for parallel task execution, suggesting the future of agentic coding may be multi-model by default. On the framework side, Gradio's new server class lets developers pair any custom front-end React, Svelte, plain HTML with Gradio's queuing, concurrency management, and zero GPU support, essentially turning Gradio into a backend framework. A text-behind-image demo ships the entire ML backend in about 50 lines of Python, while the front end is a 1-3 HTML app. Functions decorated with app.ap get Gradio's queue automatically. Standard FastTP routes coexist for static content. For anyone building AI-powered web tools on Hugging Face spaces, this removes the forced choice between Gradio's infrastructure and design freedom. From codons to geopolitics, AI beyond the keyboard. OpenMed's mRNA language model pipeline is the kind of work that makes you recalibrate what $165 in compute can accomplish. Starting from the question, which transformer architecture works best for codon-level language modeling, they compared CodonBERT, ModernBERT, and RoBERTa variants on 250,000 coding sequences from RefSec. The result was unambiguous. RoBERTa outperformed ModernBERT by 6x on perplexity 4.01 versus 26.24. Pre-trained NLP weights actively interfered with learning codon statistics. ModernBERT's English language inductive biases were baggage, not bootstrapping. The most surprising finding was that hyperparameter tuning, specifically halving the learning rate and doubling warm-up, produced 16x better correlation with biological codon preferences despite marginally worse perplexity. In other words, MLM loss alone does not measure biological relevance. They then scaled to 25 species, trained 4 production models in 55 GPU hours, and built a species-conditioned codon optimization system that no other open-source project offers. The full pipeline ESM fold for structure prediction, protein MPNN for sequence design, Codon RoBERTa for codon optimization runs end-to-end with reproducible code. For anyone working in therapeutic mRNA, vaccines, or recombinant protein production, this is directly applicable infrastructure. Luno Studio launched an AI creative academy covering animated stories, UGC videos, voice acting, creative direction, and photorealism, positioning itself as the production-grade curriculum for AI content creators moving past the cool demo phase into repeatable workflows. And on the geopolitical front, Iran's threats against the $30 billion Stargate AI hub planned for Abu Dhabi add a kinetic dimension to AI infrastructure planning. The facility, designed to house advanced NVIDIA GPU clusters and proprietary OpenAI architectures, hasn't broken ground yet, but the threat calculus is already reshaping investment risk models for Middle Eastern AI compute. The comment section's dismissiveness "there are no buildings or GPUs on site" misses the point. It's the deterrent effect on future capital allocation that matters, not the current construction status.